Hello, welcome back. In this video, we'll discuss the Zener diode. In the case of a PN junction diode, while the PN junction diode is reverse biased, at a particular voltage called the breakdown voltage, suddenly a large reverse current starts flowing in the circuit. We have said that it is due to the breakdown of the diode, and under the breakdown conditions, we have also said that the covalent bonds will be broken. As a consequence, a large number of free charge carriers will be released into the diode, and those free charge carriers are responsible for the conduction in the reverse biasing condition at the breakdown point. But when the diode reaches the breakdown point, it will undergo permanent physical damage. As a result, one cannot reproduce the IV characteristics of the diode. So the diode goes into permanent damage mode. To address this problem, Clarence Melvin Zener has developed a diode which is popularly known as the Zener diode. A Zener diode in a circuit is represented using the symbol. We'll have a triangle. At the vertex of the triangle, you have a symbol like this, inverted Z, and from the base of the triangle, you have another terminal. The terminal on the vertex side is called as the cathode, and the terminal on the base side is called the anode. A Zener device specially designed to operate in the breakdown region of the reverse bias. A Zener diode is a semiconductor device specially designed to operate in the breakdown region of the reverse bias. So a Zener diode is a semiconductor device specially designed to operate in the breakdown region of the reverse bias. The earlier PN junction diode, it is not designed to operate in the breakdown region, and this particular Zener diode is designed specially to operate in the breakdown region. The Zener diode is always operated in the reverse bias condition. It is designed to operate in the reverse biasing condition, and it works always close to the breakdown region of the reverse bias. Another interesting point is the Zener diode acts similar to an ordinary diode in the forward bias condition. In the reverse biasing condition, when the voltage is increased, one can find a small current in the circuit, and this is called the leakage current that flows through the circuit, and the leakage current is mainly due to the minority charge carriers. In the reverse bias condition, a small leakage current flows. The leakage current is due to the minority charge carriers. At a particular value of the reverse voltage, the current increases suddenly. The voltage is called the breakdown voltage or the Zener voltage, represented with a V sub Z. So at a particular voltage, a sudden increase in current is observed. The voltage is called Zener voltage, represented with a V sub Z. A Zener diode can be designed to have a specific value for the Zener voltage, that is Vz. The Zener diodes are designed to have a very low value for the Zener voltage. Generally, the Zener diodes are designed to have Vz, that is Zener voltage, about 2.4 volts. The beauty of Zener diode is, in the reverse bias condition, near the breakdown voltage, one can achieve what is known as controlled breakdown. And this controlled breakdown is reversible. Unlike the PN junction diode, when the diode reaches the breakdown voltage, it undergoes a permanent damage. Whereas in the case of Zener diodes, we'll have a controlled breakdown taking place. As a result, the breakdown is reversible. Another interesting point is, in the Zener region, the voltage across the Zener diode remains constant, but the current changes depending on the supply voltage. This is one interesting aspect of the Zener diode. In the Zener region, the voltage across the Zener diode remains constant, but the current changes depending on the supply voltage. By suitably changing the doping, one can modify the Zener voltage of a given Zener diode. And the Zener diodes are available in the ranges of 2 volts to 200 volts. Zener voltages can be modified by suitably doping the materials, means both the P and N semiconducting materials. Zeners can be designed to operate between 2 volts to 200 volts. Now we shall see the IV characteristic curves of the Zener diode. As said before, the Zener diode will act as an ordinary PN junction diode in the forward bias. So it will be just like that. Whereas in the reverse biasing condition, we see that a very small current flows through the circuit due to the leakage currents. The leakage currents are mainly due to the minority charge carriers, and the reverse biasing condition for the majority charge carriers will act as a forward biasing condition for the minority charge carriers. As a result, you will have a small current in the circuit. And for the voltage which is designated as the breakdown voltage or the Zener voltage, suddenly a large current flows through the circuit. The current is called as the avalanche current. In this video, we have seen what a Zener diode is. We have said that to overcome the permanent damage of the PN junction diodes in the reverse biasing condition near the breakdown voltages, Clarence Melvin Zener has developed a semiconducting device known as the Zener diode. We have seen the symbol of the Zener diode, and we have said a Zener diode is a semiconducting device specially designed to operate in the breakdown region of the reverse bias. The Zener diodes are always operated in the reverse bias condition only. Zener diodes acts similar to ordinary diode in the forward biasing condition, and in the reverse biasing condition a small leakage current flows through the circuit, and the leakage currents are due to the minority charge carriers. At a particular voltage, a sudden increase in the current is observed. The voltage is called as the Zener voltage, represented with Vz. Zener diodes are designed to have Vz close to 2.4 volts. In the reverse biasing condition near the breakdown voltage, controlled breakdown can take place in the case of Zener diodes, which is a reversible process. In the Zener region, the voltage across the Zener diode remains constant, but current changes depending on the supply voltage. Zener diodes can be modified by suitably doping the materials, that is the P and N type materials. Zener diodes can be designed to operate between 2 and 200 volts. We have seen the IV characteristic. We have said the leakage currents are responsible for the small current in the reverse biasing condition. In the forward biasing condition, it works just like a PN junction diode. Under the reverse biasing condition, up to the voltage Vz, a small current flows through the circuit, and this small current is mainly due to the minority charge carriers. Over and above Vz, there will be a sudden change in the current. This current is called avalanche current, and the voltage is called reverse voltage. Thank you.